Hello and welcome back to Problem Bank 7A number 15. The end of a cutting cord on a gas-powered weed cutter is 0.15 meters in length. If the motor rotates at a rate of 20 revolutions per second, what is the tangential velocity at the end of the cord? So omega is going to be 20 revolutions per second. Now notice how we are looking at revolutions per second, and we need to turn that to radians per second. And we know that there is one revolution, one time all the way around a circle, per 2 pi radians. So our unknown is our tangential velocity, v sub t. Our equation we'll use is v sub t is equal to our radius times omega, or angular velocity. Substitute everything in. We have v sub t is equal to 0.15 meters times 20 times 2 pi. And that is equal to 40 times 0.15 times 3.14, 18.84 meters per second, or 19 meters per second. Number 17, an ice skater moves in a circle on a frozen pond. The ice skater has a tangential speed of 1.5 meters per second. And an angular speed of 0.33 radians per second. So our angular velocity is 0.33 radians per second. What is the radius of the circle in which the skater moves? Same equation as before. Our tangential velocity is going to be equal to our radius times our angular velocity. Substituting everything in, we'll see 1.5 divided by 0.33 is equal to r. And our solution is 4.5 is equal to r. That is 4.5 meters. Here we have meters per second divided by radians per second. We see that our seconds cancel out. Number 19, a 15-meter radius grinding wheel starts at rest and develops an angular velocity of 12 radians per second in a time of 4 seconds. So we have quite a loaded sentence there. Delta t is equal to 4 seconds. Our initial angular velocity equals 0. Our final angular velocity is equal to 12 radians per second. What is the average tangential acceleration of a point on the wheel's edge? So our unknown is a sub t. I apologize for my T's, they look like F's. Our equation is going to be A sub t is equal to our radius times alpha. In order to find alpha, we need to do our change in velocity multiplied by our time. Is equal to our, divided by our time, change in velocity over time, or this is actually omega. Okay, so we have -12 minus 0 divided by 4. Then we're going to take that. That's going to be 3. We're going to take that. We're going to plug it back into our equation where our tangential acceleration is equal to 0.15 times 3. And our solution is going to be 0.45 meters per second squared. That is equal to our tangential acceleration. Okay. Number 21. The largest tire ever made had a radius of 1.75 meters. Suppose this tire underwent a linear acceleration of 0.83 meters per second squared. Linear is the same as tangential, right? Because as we look at our circle, when we look at tangent line that's touching in one point, we notice one thing. We notice a couple things. Well, one is that this line touches at one point. The other is this line is straight. So when we think of linear, we should think of a straight line. So our tangential or linear acceleration is equal to 0.83 meters per second squared, or the angular acceleration of the tire bend. So unknown is alpha, or angular acceleration. Our equation, same as before. Our tangential acceleration is equal to our radius times alpha. Substitute everything in, we see that 0.83 divided by 1.75 is equal to alpha, and our solution is let me recalculate that. 0.83 divided by 1.75. That sounds better. I typed in 83 first, so our angular acceleration is 0.47 radians per second squared. Number 23. An airplane propeller undergoes an angular acceleration of 42 radians per second squared. If the tangential acceleration of the propeller's tip is 64 meters per second squared, what is the propeller's radius? So our known, what is our radius? Our equation, exactly what we had before. substitute everything in. We'll say 64 divided by 42 is equal to R. This will be radians per second squared. Be meters per second squared. Our second squares will cancel, and we'll end up with meters per radius, which is 64 divided by 42, 1.52 or 1.5 meters. And 25, a compact disc has a radius of 6 centimeters. So one lookout right here, we are given centimeters, and so we will take our radius of 6 centimeters and convert that right away to meters, and we know there is 100 centimeters per 1 meter. So 0.06 meters. Suppose this disc undergoes an angular acceleration of 35.2 radians per second squared. So alpha is equal to 35.2 radians per second squared, which is the tangential acceleration of the dust speck located on the rim of the disk. So that's by telling that the dust speck is on the rim, we know that the radius of the disk is what we will use. So our known is our tangential acceleration. And our equation, nothing new here. R times alpha so 0.06 times 35.2, 2.1. meters per second squared. That concludes 7A.